The world has a huge problem with plastics. While they're a materials scientist's dream in terms of their properties, they are unfortunately an environmentalist's worst nightmare because they don't break down naturally and they're really hard to recycle. But Athena Anastasaki from ETH Zurich has set herself the goal of making plastics that can be recycled more easily. And now she thinks she's getting close. Athena, first of all, before we hear about your solution, tell us, why are the present generation of plastics a real headache?
So present plastics cannot unfortunately be recycled an unlimited number of times, as when you do traditional recycling methods, you have to heat up the plastic a lot. That's over 300 degrees Celsius in order to reprocess them and make a new product. So the problem is that at these very high temperatures, you also damage the material itself. And so the recycled product will be typically of lower quality than the original material. Now, regardless of the number of recycling cycles, plastics will eventually end up in the landfills, and it takes a long time for them to be degraded. Even worse, as they degrade, they break down to smaller plastic. This is known as microplastic, and this eventually ends up in our food and bodies. So it never really fully goes away.
And so that heating degrades the quality of the material. So therefore, your argument would be if we can avoid having to heat the thing so much, we would have material that would have a longer recyclable lifetime.
Spot on. So an alternative way to traditional recycling that we just discussed about is chemical recycling. Our group is focusing on taking a polymer, which is another word to say plastic, and by applying relatively mild conditions this time, we want to reverse the polymerization process, and as a result, we fully regenerate the starting materials. So by getting the starting materials intact rather than damaged, as in the previous method, we can then use them again to either remake the same product we started with or a completely different product of equal quality this time. The idea behind is that we would be able to minimize the wasted plastic by being able to reuse as much of it as possible.
Would you have to start with a different material, a different building block to make the polymer then that is more amenable to being degraded at a lower temperature back into its building blocks? Or can this be retrofitted to existing plastics?
You don't have to change the building block, Chris, but you would have to change the polymerization method.
So how do you actually do this then?
So the way we do this is we are able to incorporate a special chemistry group at the end of the plastic or the polymer chain, and this magic end group can then unzip the plastic all the way back to the building blocks.
And by that special group being there, it's almost like a weak link in the chain that you can pull the pin and they all fall apart into the building blocks again much more easily.
Exactly.
Does that change the properties of the plastic, though? Because obviously the plastics we've got, we think they're wonderful in terms of how they perform and how long-lived they are, and sometimes we want those aspects. We don't want to sacrifice or surrender that. It's just the recycling question comes along as a headache afterwards. So if we use your technique with these special chemical groups to aid recycling, does that affect the materials' properties of the plastics?
The good news are that it doesn't really affect the properties because the plastics are usually composed of, let's say, millions of building blocks. So all we do is change the chemical group at the very end of the polymer chain. This will be changing one building block out of millions, so that has absolutely minimal effect on the properties.
Sounds very encouraging. And just very briefly, is this a scalable process? Could all of the industries currently making plastics begin to use your technique and therefore make much better to recycle plastics very easily?
I'm optimistic. We are currently working on scaling up the process from grams to kilos. And before we fully focus on scaling up the process, we also want to expand our work to other types of plastic. So move away from the plexiglass we can do and be able to also recycle polystyrene in a similar fashion.
Athena, thank you very much for joining us to talk about it. That's Athena Anastasaki from ETH Zurich with, I hope, a solution to our present headache with recycling plastic. We can have our cake and eat it, literally. We have all the same properties and fewer of the problems. She published that work this week in the Journal of the American Chemical Society.